Hello, in this lecture we will find the size of 2 times AP, or the value of 2 times AP. We have in the picture triangle ABC. Side AC of the triangle equals to 70 units. Side BC of triangle ABC equals to 50 units, and the side AB of the triangle equals to 90 units, and we have a circle, and the center of that circle is P, and point P is on side AB of the triangle, and also side AC of the triangle is tangent to the circle at point, we will call that point E. Again, side AC of the triangle tangent to the circle at point E, and side CB of the triangle is tangent to the circle at point, we'll call that point O. Again, side CB of the triangle is tangent to the circle at point O, or the touching point of the tangent with the circle is point O here, and the touching point of the tangent with the circle is point E here. Now we will connect points C and P together. We also will connect points E and P together with a straight line. As you can see from the picture, line EP is actually the radius of the circle. I will mark it as R because it starts from the center of the circle, point P, and ends at point E on the circle, so it is defined as the radius of the circle, so EP is the radius of the circle. And then we will connect points E and P together, and actually PO is also the radius of the circle. It's exit from point P and ends at point O on the circle, so it is defined as the radius of the circle. Okay, so actually we have a rule that if you have a circle and from external point of the circle, let's call the external point of the circle point V, and actually it is external point of the circle because point V is not inside the circle nor on the circle, but it is outside the circle, and for that reason it is called external point of the circle. So if from point V we will draw two tangents to the circle, the first tangent, this is the first tangent to the circle. Let's call the touching point of the tangent with the circle F, and we will draw the second tangent from point V to this circle. And this is the second tangent from point V to this circle. Let's call the touching point of the tangent with the circle L. Then we can say that VF equals to VL. Okay, so the rule is that if from external point of any circle you draw two tangents to that circle, then those two tangents are equal to each other. In this example, tangent VF equals to tangent VL. Tangent VF is equal to tangent VL. Okay, or VF equals to VL. So actually we can implement this rule on our circle, because in our circle we have external point of the circle, that is to say point C is external point to this circle, and from point C we have two tangents. The first tangent to this circle is CO, and the second tangent to this circle is CE. Therefore we can deduce from our rule that CO equals to CE. Okay, CO equals to CE. Okay, CO equals to CE according to the rule that I have mentioned, that if from external point of a circle you draw two tangents to the circle, then those two tangents are equal to each other. For that reason, CO equals to CE. Okay, but we also know that EP is the radius of the circle and OP is also the radius of the circle. So EP also equals to OP. Okay, or PE equals to PO. Okay, PE, that is the radius of the circle, equals to PO, that is also the radius of the circle. Okay. Again, PE equals to PO equals to the radius of the circle, okay? PE equals to PO equals to the radius of the circle. and also PC, this line equals to itself, okay? PC equals to PC. Okay, so CO equals to CE, PE equals to PO, and PC equals to PC. So therefore we can say that the three sides of the green triangle are equal to three sides of the black triangle. Because CE, side CE of the green triangle is equal to side CO in the black triangle, side PE in the black triangle is equal to side PO in the black triangle, and side CP in the green triangle is equal to side CP in the black triangle. So we have three sides of the green triangle that equals to three sides of the black triangle. Therefore, we can deduce that triangle CEP is congruent to triangle COP. Again, triangle CEP is congruent to triangle COP because three sides of triangle CEP, the green triangle, are equal to three sides of triangle COP, the black triangle. Okay, therefore triangle CEP is congruent to triangle COP. Okay. So from the fact that the green triangle is congruent to the black triangle, we can deduce that angle PCE in the green triangle equals to angle PCO in the black triangle. So because of the fact that the green triangle is congruent to the black triangle, we can deduce that angle PCE in the green triangle equals to angle PCO in the black triangle. And okay, angle PCE in the green triangle equals to angle PCO in the black triangle. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, according to the rule that corresponding angles in congruent triangles are equal to each other. The green triangle congruent to the black triangle, therefore angle PCE in the green triangle is equal to angle PCO in the black triangle. Okay, so if we mark angle PCE in the green triangle as theta, then angle PCO in the black triangle must be also theta, because those two angles are equal to each other. Okay, angle PCE in the green triangle equals to angle PCO in the black triangle. Therefore, if angle PCO is called theta, then if angle PCE is called theta, then angle PCO also is theta, because those two angles are equal to each other. Okay, so now I will draw triangle ABC and again. So this is triangle ABC. We have the size of each side of the triangle, and P is the center of the circle, and actually we have two angles that equals to each other. So we actually can define line PC as angle bisector, because it splits angle ACB in the triangle to two halves. Okay, because of the fact that PC or CP splits angle ACB to two halves, we can define CP, the line in the red color, as angle bisector. Okay, so CP is angle bisector, Okay, CP is angle bisector because it splits angle ACB in the triangle to two halves. This is the first half and this is the second half. Okay, so now according to the angle bisector theorem, an angle bisector divides the side that it hits in a ratio that equals to the ratio of the angles sides. Okay, I will repeat again on the angle bisector theorem, and 1 minute. An angle bisector in a triangle okay, I will read again the angle bisector theorem. The angle bisector theorem states that an angle bisector in a triangle divides the side that it hits in a ratio that equals to the ratio of the angle's sides. Now I will explain in detail the meaning of the theorem. An angle bisector in our specific example is CP is defined as angle bisector in a triangle. In our specific example, we relate to triangle ABC. So CP is angle bisector in triangle ABC, and the theorem statement is that an angle bisector in a triangle divides the side that it hits. The angle bisector CP hits side AB, and the theorem says that it divides that side in a ratio that equals to the ratio of the angle's sides. So actually angle bisector CP is side AB, and it divides side AB to two parts, to part AP and to part PB. And the ratio between those two parts is AP over PB. And that ratio, according to the theorem, equals to the ratio of the angle's sides. First of all, we relate to the angle that is divided to two halves. And this is angle ACB. Angle ACB divided to two halves. This is the first half and this is the second half. So we relate to angle ACB in a ratio that equals to the ratio of the angle's parts. So in a ratio that equals to the ratio of the angles ACB sides. Angle ACB consists of two sides. It consists side AC and also it consists side CB. And the ratio between those two sides is AC over CB. So the ratio that angle bisector CP divides side AB equals to the ratio of the angle sides of ACB, of angle ACB sides. That is to the ratio of the angle ACB sides. That is to say, AC over CB equals to the ratio that angle bisector CP divides side AB. So the ratio that angle CP divides angle AB, that is to say AP over PB, equals to the ratio of the angle's sides. That is to say AC over CB. Okay, so I will write it here. So the ratio that angle bisector CP divides side AB is AP over PB. And according to the theorem, that ratio equals to the ratio of the angle's sides. And the ratio between the angle's sides is AC over CB. Okay, because we relate to the angle that is divided to two halves by angle bisector CP. So we relate to angle ACB, and the ratio between its sides is AC over CB, because angle ACB consists of two sides, side AC and side CB, and the ratio between those two sides is AC over CB. Okay, so the ratio that angle bisector CP, the red line, divides side AB is AP over PB, and this ratio equals to the ratio of the angle's sides, and the ratio of the angle's sides is AC over CB. So AP over PB equals to AC over CB. Okay, so I will repeat again. The angle bisector theorem states that an angle bisector CP in a triangle ABC divides the side that it eats. CP eats side AB of the triangle, and it divides it to two parts, part AP and part PB, and the ratio between those two parts is AP over PB. So this ratio is equal to the ratio of the angle's sides. We relate to angle ACB, and the ratio between its sides is AC over CB. So the ratio that angle CP divides side AB is equal to the ratio of the angle's sides. That is to say AC over CB, or AP over BP equals to AC over CB. Okay, so the angle bisector CP in triangle ABC divides side AB to two parts, to part AP and to part PB, and the ratio between those two sides is AP over PB, and this ratio equals to the ratio of the angle's sides to the ratio of to the sides of angle ACB, and the ratio between the angle ACB sides is AC over CB. So AP over PB equals to AC over CB. Okay? So the ratio that angle bisector CP divides divides side AB equals to the ratio of the angle sides, that is to say AC over CB. Okay? Again, the angle sides we relate to the angle that is divided to two halves by angle bisector CP, that is to say we relate to angle ACB in triangle ABC, and angle ACB consists of two sides, that is to say side AC and side CB, and the ratio between those two sides is AC over CB, and that ratio equals to the ratio that angle bisector CP divides side AB, that is to say AP over PB. So the ratio that angle bisector CP divides angle AB, that is to say AP over PB, equals to the ratio that of the angle's sides, and the ratio of the angle sides is AC over CB. So AP over PB equals to AC over CB. Okay? So I will write the equation again. I will mark it as equation 1. AP over PB equals to AC over CB. So actually this is the equation 1 of the angle bisector theorem, and actually we can define that AP equals to X so PB will be equal to AB minus AP, that is to say to 90, because AB equals to 90 units, minus AB is X, so it is 90 minus X, so PB will be equal to 90 minus X. Okay, so AP equals to X and PB equals to 90 minus X. So I will write down those two identities. AP equals to X, so PB equals to 90 minus X. Okay, according to our definitions, AP equals to X, so PB must be equal to 90 minus X, and here we can, in equation 1, we can substitute AP by X and PB by 90 minus X. Okay. So here I substituted AP by X because AP equals to X, and PB by 90 minus X because PB equals to 90 minus X. But we also know it is given to us that AC equals to 70 units and CB equals to 50 units. So I write it down. AC equals to 70 units and CB equals to 50 units. Okay, so we can substitute AC by 70 and CB by 50. Okay. Okay. Here I substituted AC by 70 because AC equals to 70 and CB by 50 because CB equals to 50. Now 70 equals to 7 times 10 and 50 equals to 5 times 10. So I write it down. Okay, so here I will substitute 70 by 7 times 10 and 50 by 5 times 10 in equation 1. Okay, substituted 70 by 7 times 10 and 50 by 5 times 10. Now we have 10 in the numerator and we have also 10 in the denominator, so we can cancel 10. We will write it again. So x over 90 minus x equals to 7 over 5. So here I cancel 10 because we have 10 both in the numerator and in the denominator. So we can cancel 10. So we got that x over 90 minus 6 equals to 7 over 5. Now we can multiply both sides of the equation by 5. So we multiplied both sides of the equation by 5, so 7 divided by 5 times 5 equals to 7, and x over 90 minus 6 times 5 equals to 5x over 90 minus 6. Now we will multiply both sides of the equation by 90 minus 6. Actually, it is allowable to multiply both sides of the equation by 90 minus 6 because x AB equals to x and AB equals to 90. So x is less than 90, so 90 minus x will be a positive number. And 90 minus 6 can never be 0. For that reason, it is allowable to multiply both sides of the equation by 90 minus 6. Okay. So here we multiply both sides of the equation by 90 minus 6. 5x divided by 90 minus x times 90 minus 6 equals to 5x, and 7 times 90 minus 6 equals to 7 times 90 minus 6. Now I will open the brackets here. So here we have 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x. Now we will add 7x from both sides of the equation to both sides of the equation. We'll get that 12x equals to 630. I will repeat. We added 7x to both sides of the equation, so 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Now we'll divide both sides of the equation by 6. So we'll get that so here we divided both sides of the equation by 6, so 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. But we also know that x, we defined x, AP equals to x, yes? So we can write it here that AP equals to x, and if AP equals to x, 2 times AP equals to 2x, okay? According to our definition, AP equals to x, so 2 times AP equals to 2 times x. So 2 times x equals to 105, and 2 times x equals to 2AP. So we can write that 2 times x equals to 105 equals to 2 times AP, because 2x also equals to 2 times AP. Okay, so here we have 2 times 6 equals to 105, and 2 times 6 equals to 2 times AP, so we can add that 2x equals to 2 times AP, so we got that 2 times AP equals to 105, okay? And actually this is our final answer to the question, that 2 times AP equals to 105 units. Okay, from here we got that 2 times AP equals to 105 units, and actually this is the answer to our question. The value of 2 times AP is 105 units, so the size of 2 times AP is 105 units. So actually, now I will summarize the lecture. So we actually wanted to find the size of 2 times AP. We have a triangle with size AC equals to 70 units, size AB, the size of side AB equals to 90 units. I will repeat, the size of side AC of the triangle is 70 units, and the size of side CB of the triangle is 50 units. We have also a circle that is center is P, and also side AC of the triangle is tangent to the circle at point E, and side BC of the triangle is tangent to the circle at the point O, and actually we also have a rule that if from external point of a circle we draw two tangents to that circle, then those two tangents are equal to each other. In this example, we draw an external point of this circle, that is point V, and we draw two tangents to this circle. For that reason, VF is equal to VL. So we can implement this rule in our circle, because in our circle we have from external point of this circle, that is to say from point C, we draw two tangents to this circle, tangent CO and tangent CE, and because we draw from external point of this circle two tangents to this circle, therefore they are equal to each other. That is to say, CO equals to CE, and also PE equals to PO equals to the radius of the circle, and PC equals to itself. For that reason, the green triangle is congruent to the black triangle, because three sides of the green triangle are equal to three sides of the black triangle. For that reason, those two triangles are congruent to each other, and for that reason, angle PCE equals to angle PCO, according to the rule that corresponding angles in congruent triangles are equal to each other. So we called the angle PCE theta, so angle PCO also be theta, because those two angles are equal to each other. And we draw triangle ABC again. Okay, so this is triangle ABC, and CP, actually, as you can see here, CP is here, and I draw it here in the red color. As you can see here, CP divides angle ACB to two halves. This is the first half and this is the second half, and for that reason we can call line CP angle bisector, because it divides angle ACB in triangle ABC to two halves. And according to the angle bisector theorem, an angle bisector, that is to say CP in a triangle ABC, divides the side that it eats. CP eats side AB and divides it to two parts, to part AP and to part PB, and the ratio between those two parts is AP over PB, and that ratio is equal to the ratio of the angle sides. We relate to angle ACB that is divided to two halves by CP, the angle bisector, and this angle ACB consists of two sides, side AC and side CB, and the ratio between those two sides is AC over CB. That ratio, AC over CB, equals to the ratio that angle bisector CP divides side AB. That is to say, AP over PB. Angle bisector CP divides angle AB in a ratio that equals to AP over PB, and that ratio equals to the ratio of the angle sides, that is to say AC over CB, or AP over PB equals to AC over CB. So according to the angle bisector theorem, actually we use this equation and we defined AP as x and PB as 90 minus x. So we can substitute AP by x and PB by 90 minus x, and AC by 70 and CB by 50. And actually we got here one equation with one variable only, and we got to the final answer that 2x equals to 105, or 2 times AP equals to 105, and this was actually the question. And the answer to that question is that the size of 2 times AP is 105 units, so the value of 2 times AP is equals to 105 units. Okay, thank you very much.